Imagine you're surfing off the coast of Florida. Warm water, perfect waves, total bliss. Now imagine something 55 feet long rising beneath your board. Something that could swallow a dolphin whole without chewing. Something with a bite force 10 times stronger than a T-Rex. That creature was real. It ruled every ocean on Earth for 20 million years, and then it vanished. Scientists still argue about why. Today we're going to talk about 5 facts about the Megalodon that are more terrifying than any Hollywood movie. Not because they're fiction, because every single one of them is true. Here's something that will mess with your head. We have no idea what Megalodon really looked like. I'm serious. There are reconstruction models in museums all over the world. There are textbook illustrations. There are blockbuster movies. But the truth is, almost all of it is educated guesswork. A shark's skeleton is made entirely of cartilage, not bone, cartilage. That's the same flexible tissue in your nose and ears. After a shark dies, cartilage dissolves within years. It leaves behind almost nothing. So when Megalodon died, what remained were only the hard parts, teeth and occasionally vertebrae. That's it. Teeth and a few vertebrae. That's all Megalodon left behind across 20 million years on this planet. And from those teeth, scientists have spent over 150 years trying to reconstruct what this animal looked like. The first major reconstruction happened in 1909. A guy named Bashford Dean assembled a massive jaw model, about 6 feet tall. A full-grown adult could walk inside it and stand upright. A photo of Dean standing inside that open jaw became one of the most iconic scientific images of the 20th century. It also turned out to be one of the most embarrassing mistakes in paleontology. The teeth were incorrectly placed. The size was grossly overestimated. But that image, that terrifying open mouth big enough to swallow a person, was burned into popular culture forever. The math puts Megalodon at roughly 50 to 60 feet long. Some estimates go as high as 65 feet. That's the length of a semi-truck and trailer combined. Or imagine 5 or 6 full-size SUVs bumper to bumper. That's one shark. Weight estimates range from 50 to 100 tons. That's comparable to a sperm whale. The open jaws would have spanned about 11 feet across, wide enough to swallow a large dolphin in a single gulp without chewing. For decades, the standard approach was, take a great white shark, scale it up 3 or 4 times, boom, Megalodon. Megalodon teeth look similar to great white teeth. Triangular, serrated edges, designed for slicing through flesh. Based on this similarity, Megalodon was classified in the same genus as the great white. It appeared in textbooks for decades as Carcharodon Megalodon. But in the last 20 years, that picture changed completely. Detailed analysis showed the similarity between Megalodon and the great white is purely superficial. The internal anatomy of the teeth, the pattern of serration, the microscopic structure, all of it points to a completely different family, which split off over 100 million years ago. The modern scientific name is Otodus Megalodon. It means Megalodon was not a giant great white shark. It was something entirely different. In 2022, a team published a 3D body reconstruction based on the only complete vertebrate specimen ever found, discovered in Belgium. Megalodon wasn't a sleek torpedo-shaped predator. It was massive, wide-bodied, almost barrel-shaped, with a short snout and a disproportionately large head. In terms of proportions, it looked more like a whale shark, though with a completely different lifestyle. This reconstruction sparked fierce debate. Some paleontologists accepted it, others pushed back hard. After 150 years of study, we're still arguing about what this animal's basic body shape looked like. That alone tells you how little we actually know. A single Megalodon tooth can be up to 7 inches long. A great white shark tooth is about 2.5 inches. Megalodon's tooth is nearly 3 times longer, about the size of an adult human hand. The serrated edge isn't decorative. Every single notch works like a microsaw, slicing through flesh with any movement of the jaw. Megalodon had around 270 teeth arranged in 5 rows. As front teeth wore down, they were replaced by the row behind, a non-stop assembly line running for the shark's entire life. Over one lifetime, a single Megalodon could produce and shed up to 20,000 teeth. You can find Megalodon teeth on beaches from North Carolina to Australia, from Morocco to Japan. The ocean floors are literally covered in them. In 2023, a study from UCLA and the Max Planck Institute dropped a bombshell. Megalodon ran hot, way hotter than the ocean it swam in. The scientists used something called isotope thermometry. The ratio of isotopes locked inside tooth enamel reflects the body temperature of the animal at the exact moment that tooth was forming. By measuring those ratios in fossilized Megalodon teeth, they calculated its actual body temperature while alive. The result: Megalodon's body temperature was approximately 95 to 104 degrees Fahrenheit. That's 13 to 15 degrees above the surrounding ocean water. That's right in the range of human body temperature. The great white stays only about 10 to 12 degrees above water temperature. Megalodon blew past even that. This means Megalodon actively generated its own heat and maintained a stable internal temperature regardless of the environment. Think of it like the ocean's version of a warm-blooded mammal. Warm muscles contract faster and with more power. A warm brain processes information more efficiently. A warm body allows you to hunt in cold water where cold-blooded predators simply cannot go. Megalodon could chase prey from the tropics to near-polar latitudes without losing effectiveness. It was a universal killing machine, an apex predator tuned to run at full power in any ocean on Earth. Megalodon's cruising speed was around 3 miles per hour, slow and steady for a giant, but during an attack, it could burst to 20 miles per hour. Fast enough to overtake most whale species, whose typical cruising speed sits between 2 and 5 miles per hour. A 50-ton shark hitting a whale at 20 miles per hour is not an attack. It's a collision. The momentum alone could stun or even kill a smaller whale before the jaws even made contact. It's like being hit by a freight train moving at highway speed. But this superpower came with an impossible price tag. Maintaining that high body temperature burns through calories at a staggering rate. An adult Megalodon needed to consume the caloric equivalent of roughly 1 full-grown dolphin every single day, or a significant portion of a young whale every day. When food became scarce, Megalodon couldn't just slow down. Its own body kept demanding fuel. The warm-bloodedness that made it king of the ocean became its greatest vulnerability. Megalodon ate whales. We know this, not from theories or models, from physical evidence. Direct, undeniable, fossilized crime scene evidence. Paleontologists around the world have found whale bones with deep parallel grooves etched into ribs, shoulder blades, and vertebrae. These grooves match Megalodon tooth dimensions with precision. Some of those bones show signs of healing, meaning the whale survived the attack and lived on. Others don't. The attack was fatal. In 2021, a team from the University of Zurich built a computer model of Megalodon's bite. Megalodon's bite force was between 40,000 and 62,000 pounds of force. That's approximately 10 times stronger than a T-Rex and 35 to 40 times more powerful than a great white shark's bite. With that kind of force, Megalodon could crush the rib cage of an adult whale in a single jaw closure, shattering bones and destroying internal organs, compressing the body like an aluminum can. But the most fascinating part isn't the raw power, it's the strategy. Marks found on tail fins and shoulder structures suggest the predator first disabled its prey by damaging the fins and flippers, immobilizing the whale before delivering the killing blow to the chest. This is not the mindless lunge of a hungry predator. This is a calculated hunting tactic. Modern great white sharks use a strikingly similar approach when hunting sea lions. First strike immobilizes, second strike kills. Megalodon did exactly the same thing, but its sea lions were whales the size of city buses. In North Carolina, paleontologists uncovered the remains of a young baleen whale, almost a complete skeleton, with dozens of Megalodon bite marks on nearly every major bone. Scattered around the skeleton were several shed Megalodon teeth. Megalodon killed the whale, dragged it down, and methodically consumed the carcass. A 10-million-year-old crime scene frozen in rock, perfectly preserved, waiting 10 million years for someone to show up and figure out what happened. Megalodon teeth have been found on every continent on Earth, including Antarctica, from North Carolina to Chile, from the Mediterranean to Japan to the Australian coast. No other marine predator of comparable size has ever achieved that kind of global distribution. It was the most cosmopolitan apex predator in the history of life on Earth. But that distribution wasn't random. The smallest teeth belonging to juveniles clustered overwhelmingly in shallow coastal zones in tropical and subtropical regions. This led researchers to a major hypothesis. Megalodon had dedicated nursery areas. These were specific coastlines where females gave birth and where young megalodons spent their early years. The warm, shallow water provided optimal growing temperatures. The abundant, smaller prey fueled rapid growth. As juveniles matured, they gradually moved offshore and graduated to hunting larger and larger prey, eventually targeting whales. In 2020, scientists identified 5 nursery sites around the world. In Panama, along the US East Coast, in Spain, in the Canary Islands, and in Peru. Every single one was located in a warm, shallow, protected bay with rich food sources nearby. The most striking evidence came from Panama's Gatun Formation, a geological layer about 10 million years old. Paleontologists found an unusually high concentration of small Megalodon teeth, pointing to juveniles between 6 and 20 feet long, infants and adolescents by this species' standards. Alongside the teeth were bones of small fish and minor marine mammals, exactly the prey you'd expect at a nursery site. The geological context confirmed a shallow tropical bay, protected from open ocean currents. Perfect conditions for raising young predators. When the Isthmus of Panama rose and closed the connection between the Atlantic and Pacific, those bays disappeared. When the climate shifted, ocean temperatures dropped, sea levels fluctuated, and coastlines reorganized. These nurseries began vanishing. Warm, shallow waters contracted. Young megalodons had nowhere safe to grow up. Without protected spaces to raise offspring, the population couldn't replace its losses. One of the most dominant predators in Earth's history may have been done in by losing its maternity wards. Why did Megalodon go extinct? This is one of the hottest debates in all of paleontology. There is no single clean answer, but together, the hypotheses paint a picture of a perfect storm that took down the largest predator in ocean history. Megalodon went extinct approximately 3.6 million years ago during the Pliocene epoch. Earth was entering a cycle of ice ages. Oceans were cooling, sea levels were shifting dramatically. Tropical and subtropical zones contracted, cold water pushed in from the poles, Megalodon's livable range shrank from every direction. But climate alone doesn't fully explain it. 2 other things hit Megalodon from 2 completely different angles at almost exactly the same time. First, whale migration. Baleen whales, Megalodon's primary prey, began migrating into polar waters following shifts in krill and zooplankton zones. Cold polar waters were too extreme for Megalodon. Even with its advanced thermoregulation, Arctic temperatures fell below its physiological minimum. The prey moved to an address the predator couldn't reach. Second, competition arrived. Around 3 to 4 million years ago, the great white shark began expanding and dominating coastal ecosystems. Great whites are smaller than Megalodon, but they're faster, more agile, and need dramatically less food to survive. The great white wasn't competing with adult megalodons for large whales. It was competing with juvenile megalodons for seals, dolphins, and large fish. In that competition, great whites won every time because they were more efficient. Megalodon didn't lose a fight, it lost an economic war. Then there's a third hypothesis, and it's wild. In 2018, astrophysicists proposed that a nearby supernova explosion about 2.5 million years ago sent a burst of cosmic radiation through Earth's oceans. This radiation could have dramatically increased mutation rates and cancer risk in large marine animals. The math is grim. The larger the animal, the more cells in its body, and the higher the probability of a cancerous mutation. A 50-foot megalodon would have been especially vulnerable. This hypothesis is controversial, but it elegantly explains why the largest species went extinct while smaller ones survived. Most likely, all of these factors combined. Climate change destroyed the nurseries. Whale migration eliminated the main food source. Great white competition undermined juvenile survival. Megalodon was not killed by a single bullet. It was killed by 1,000 cuts. Every trait that made Megalodon dominant, its massive size, its warm-bloodedness, its dependence on large prey, became a fatal liability the moment conditions changed. It was too large to adapt quickly, too warm-blooded to survive on less food, too specialized to pivot when its ecosystem collapsed. Nature had been extraordinarily generous, and then used that very generosity to end it. Could Megalodon still be alive somewhere in the deep ocean? Science has a clear, firm answer: no. Megalodon was a warm-blooded predator that needed enormous amounts of food, constantly. The deep ocean is far too cold and utterly lacks the prey density needed to feed a 50-ton predator. It couldn't quietly hunt whales near the surface without being noticed. Modern satellite tracking and acoustic monitoring would detect any large marine animal operating at that scale. Most critically, its teeth. Megalodon shed thousands of teeth over its lifetime. The most recent Megalodon teeth in the fossil record date to approximately 3.5 million years ago. Since then, not a single fresh tooth has been found. Not one. Anywhere. Zero. People sometimes point to the coelacanth, a fish thought extinct for 65 million years until a living specimen was caught off South Africa in 1938. If a coelacanth can hide for 65 million years, why not Megalodon? The difference is scale. A coelacanth is about 5 feet long. It lives in deep water, eats small prey, and leaves essentially no trace at the surface. Comparing it to Megalodon is like comparing a mouse living in a wall to a rhinoceros living in your living room. The mouse can hide, the rhino cannot. Megalodon is gone. That's not pessimism, that's science. Pick up a Megalodon tooth on a beach. Hold it, really hold it. It is heavy, denser than stone, polished by millions of years of sediment. It fits in your palm, but it shouldn't. Nothing this size should belong to a single tooth, and yet here it is. Proof that 10 million years ago, when our primate ancestors were barely figuring out how to climb trees, something was out there in the ocean with this tooth in its mouth. Megalodon ruled the seas for 20 million years. That's 10 times longer than our entire genus Homo has existed on Earth. It was the absolute pinnacle of predatory evolution, and then the ocean changed, and being at the top turned out to be the most dangerous place of all. The qualities that make something great in one environment can make it helpless in another. Megalodon was perfectly designed for its world and perfectly unsuited for any world but its own. When the conditions shifted, everything that made it magnificent became a trap. The ocean still carries its memory. In every dark wave, in every tooth turning slowly in the sand, the ocean remembers its kings, even the ones that have been gone for millions of years.